Hello and welcome to the maths lesson. In this video, we'll learn about Pythagoras theorem. The theorem of Pythagoras is a very well-known theorem. It is also a very old one. Not only does it bear the name of Pythagoras, an ancient Greek, but it was also known to the ancient Babylonians and to the ancient Egyptians. The actual statement of the theorem is more to do with the areas. So, before we go into the theorem, let us have a look at the area of a square. As you know, the area of a square is given by the formula side multiplied by side, and it can be written in a shortened form using index notation, which is side squared. The theorem talks about right-angled triangle. Here we have one right-angled triangle. This angle over here, marked with a small square, is a right angle. Now, we have to identify a hypotenuse. Yes, you heard it right. The hypotenuse. It is the longest side in a right-angled triangle, and also it is opposite to the right angle. So here we have a right angle. The side that is opposite this side over here is the hypotenuse. It is the longest side and it is opposite to the right angle. Now, let us draw a square on the hypotenuse. Here we have a square on the hypotenuse. And let us draw two squares on the shorter sides. Here we have one, and here we have another one. The theorem states that the area of the square on the hypotenuse is equal to the areas of these two squares, which means area of A plus area of B is equal to area of C. Area of A is going to be A times by A, which is A squared. Area of B is going to be B times by B, that is B squared. And so the area of C is going to be C times by C, that is C squared. So we can write this as A squared plus B squared is equal to C squared. Remember that Pythagoras theorem can only be used in right-angled triangles. Here is a demonstration of the theorem. The area of two squares on the shorter sides is equal to the area of the square on the hypotenuse. Alright. Here we have two right-angled triangles. Now, let's say this side is A, this side is B, and this side is C. And say, for example, A is equal to 3, B is equal to 4, and C is what we need to find. Let us use the Pythagoras theorem. That is A square plus B square is equal to C squared. Now, all you have to do is substitute the values for A and B. That will give us 3 squared plus 4 squared equal to C squared. 3 squared means 3 times 3, which gives us 9, plus 4 times by 4 is 16, is equal to C squared. 9 plus 16 gives us 25, is equal to C squared. We need to find C. So when something is squared, we need to find the square root of that. So let's find square root on both the sides. So square root of 25 and the square root of c squared. Square root of 25 is 5 and square root of c squared is just c. So there we have found the value of c is equal to 5. Let this be x, this be y, and this side z. And say z is equal to 17, y is equal to 15, and this is what we need to find. Using the Pythagoras theorem, we already have it here, a squared plus b squared is equal to c squared. In the same way, we can write the theorem as x squared plus y squared is equal to z squared. It does not make any difference, only the letters are different. So we know we have to find x. Y is 15, so substitute the value of y, 15 over here, and substitute 17 in place of z. So x squared plus 15 squared is equal to 17 squared. Now let's calculate these two numbers. X squared, 15 squared is 15 times by 15, and that is 225. So give us 17 squared is equal to 289. Now if you look at this equation, along with x squared you have 225 added. So we need to take away 225 from both sides. Take away 225 from this side and take away 225 from this side. And we need to take away 225 from 289. And that gives us 64. We need to find the square root of that. So let's find what is square root of x squared and what is square root of 64. So square root of x squared is just x, and square root of 64 is 8, because 8 times by 8 is 64. Now in these two examples, the answers have been exact. Here we have 3, 4, and C we found as 5. Here we have 15, 17, and X is 8. These three numbers are called Pythagoras triples, 3, 4, 5, 8, 15, 17, and so on. It occurs quite frequently. However, you will come across answers that are not exact. So in such cases, you're supposed to round your answer to a certain degree of accuracy, or as stated in the question. Thank you very much and have a good day.